What is dependency injection and why is it important in the Spring framework? Dependency injection is a design pattern used in software development to achieve what we call inversion of control. In simple terms, instead of a class creating its own dependencies, the dependencies are injected into the class from an external source, typically by a framework like Spring. Doing this promotes loose coupling between components, makes the code more modular, more testable, and ultimately more maintainable. In the Spring framework specifically, dependency injection is primarily done in one of three ways: either constructor injection, setter injection, or field injection. And those are just like they sound. Constructor injection is dependencies are provided via the constructor, setters by the setters, and fields are directly injected into the fields. Now there are several reasons why dependency injection is important in Spring. Dependency injection inherently decouples the components of your application. Since dependencies are injected at runtime, classes are no longer responsible for creating their own dependencies. This makes it very easy to replace or substitute dependencies with different implementations when needed. Dependency injection also improves flexibility by allowing components to be configured externally, for example through XML or Java annotations or Java-based configuration. This allows you to change behavior without actually modifying the application code. Dependency injection also helps avoid repetitive and boilerplate code that is often needed to manage dependencies. This simplifies your code, improves readability, and eases maintenance. And finally, dependency injection improves testability. Since dependencies are injected, you can easily mock or stub them during unit testing, promoting better test coverage and allowing you to write simpler test code. Now, while dependency injection in Spring offers many advantages, it also comes with some potential pitfalls that you should be aware of. One of those is tight coupling to the framework. By using annotations like auto-wired, component, and other Spring-specific features, your code does become coupled to the Spring framework. Now, this isn't the end of the world, but it does reduce portability if you ever need to switch frameworks. So preferably use constructor injection instead of field injection where possible. Constructor injection is not framework specific and therefore it keeps your code more portable. It also simplifies test configuration as it allows testing through just plain Java classes. Another pitfall is overuse of field injection. Using field injection by using the auto-wired annotation on fields makes testing harder. This is because the dependencies can only be injected by the Spring framework. To avoid this, again prefer constructor injection or even setter injection. Constructor injection ensures that dependencies are immutable and your class cannot exist without them, which makes the design cleaner and more robust. Another area to consider is configuration complexity. In large applications, the sheer number of Spring beans and configuration can become overwhelming, and this can lead to difficulty in understanding the overall structure and flow of the application. To avoid this, break down the configuration into modular and manageable pieces. Use Spring's configuration and profile annotations to segregate beans based on environment. You can also use the component scan annotation to limit scanning to specific packages, giving you more control over what gets loaded. So that's the basics of dependency injection in Spring and a few of the pitfalls we often see. To talk about this or any other topic, reach out to Ask the Team at keyholesoftware.com.